Very good morning, all of you. Welcome to my chemistry tutor. Today, let us discuss about the concept of molar volume. So, what is meant by the molar volume, and how can we find the volume of a substance if number of moles, number of molecules, and weight of the substance are mentioned? Let us discuss today. Okay, so before entering into the class, let's have a basic view about the molar volume. What is meant by a molar volume? So here, molar volume is nothing but volume occupied by 1 mole of a gas. Volume occupied by 1 mole of a gas at STP conditions. Volume occupied by a gas at STP conditions is known as a molar volume. So simply we can give a definition for this molar volume as the volume occupied by 1 mole of any gas at STP is called as a molar volume. So it is found that 1 mole of any gas, 1 mole of any gas at STP occupies 22.4 liters of volume. What is the volume occupied? 22.4 liters of volume is occupied by 1 mole of any gas. Okay, let's take some examples. At what conditions here? At STP condition. What is STP stands for? Standard temperature and pressure. So what are those temperatures? 0 degrees Celsius or 273.15 Kelvin. This is called as a standard temperature, and standard pressure is 1 atmosphere. This is taken as a standard pressure. So the value of 1 atmosphere is equal to 76 centimeters of mercury column in the barometer. So you know well 1 centimeter is equal to 10 millimeters. The value of 1 centimeter gives 10 millimeters. So we can convert this as a 760 millimeters of mercury. So the value of our atmosphere is equal to how many millimeters? 760 millimeters. So these are the conditions taken as a standard temperature and pressure. So at the standard temperature and pressure condition, 1 mole of any gas occupies the same volume, that is 22.4 liters of volume. Okay, now let's see. Let us take an example. Take 1 mole of O2 gas occupies 22.4 liters. Because this is the molar volume occupied by 1 mole of gas at STP. At what conditions here? All these are the gases are occupying the volume at STP conditions. Okay. That 1 mole of CO2 you consider. It also occupies 22.4 liters. Take 1 mole of methane gas. Formula for methane is CH4, occupies 22.4 liters. So what does it indicate? 1 mole of any gas under STP conditions occupies the volume of 22.4 liters. This is the volume occupied by 1 mole of a gas at STP conditions. It is known as the what we call molar volume. Molar volume. So what is the value of molar volume here? That is 22.4 liters. What is the value here? 22.4 liters. Right. So simply we can write molar volume is equal to, what is the value? 22.4 liters. All of you know well, 1 liter is equal to how many milliliters? That is 1000 milliliters. And it can be written as 10 to the power of 3 milliliters. It can be written as 10 to the power of 3 milliliters. So now we can convert this molar volume into the milliliters. Okay, so 22.4 liters. 1 liter is equal to 1000 milliliters. So 22.4 liters in the sense what we can write? 22.4 into 1000 milliliters. So we get 22,000 400 milliliters. This also can be considered as a value of molar volume in the milliliters. So you know where one more unit? 1 milliliter is equal to 1 cubic centimeter. It can also be written as a cc. 1 cubic centimeter. So we can write the value of molar volume. 1 milliliter is equal to 1 cubic centimeter, and we have 22,400 milliliters. So it can be written as a 22,400 cubic centimeters. All these gives the value of molar volume. Simply the basic thing which we need to remember is the molar volume is nothing but volume of 1 mole of a gas. Right? Now let us see how to find the volume of different gases based on the concept of molar volume. Okay. So before that, let's recall the concept of number of molecules and weight. Simple, the basic view of a mole. So we previously discussed, in the previous videos we discussed that 1 mole of any substance weight is equal to its gram molecular weight. It's a gram molecular weight. In the same way, 1 mole of any substance contains 6.023 into 10 to the power of 23 molecules. It means Avogadro number of molecules. And now here what we discussed? 1 mole of any substance occupies 22.4 liters. Okay. So let us assume them with the terms A, B, C, D. Assume it as A, B and C. Sorry. Take these as a ABC. A, B and C. Okay. Assume this as a D. The term D is the same. What about the terms A, B, C? They are different. So accordingly what we can write? A is equal to D. Okay. Next, B is equal to D. Then C is also equal to D. So in such a case, according to the mathematics, we can write A is equal to B, which is also equal to C. Because all the three terms are equivalent with the fourth term, right? So then we can write A is equal to B, which is equal to C, which indicates that, and this is also equal to what? D. Because all are directly equal to the G. So we can write 1 mole of a substance is equal to 6.023 into 10 to the power of 23. Okay. And which is equal to 22.4 liters, and this is also equal to its gram molecular weight. So this is the basic relation which you need to remember to go for any kind of calculations. 1 mole of any substance contains 6.023 into 10 to the power of 23 particles. 1 mole of any substance occupies 22.4 liters of volume. 1 mole of any substance weighs, its weight is equal to its gram molecular weight. Clear? Now, 6.023 into 10 to the power of 23 particles contains how many moles? 1 mole. Okay? And 22.4 liters of volume is occupied by 1 mole of a substance. Gram molecular weight of any substance contain 1 mole of a substance. Right? Now let us see the relation between the remaining three. This is what Avogadro number, right? Avogadro number of particles occupies the volume of 22.4 liters. The weight of Avogadro number of particles is equal to its gram molecular weight. In the same way, 22.4 liters of volume contains Avogadro number of particles. Gram molecular weight of a substance contains Avogadro number of particles. So we can show the relation in a vice versa, so that easily we can calculate the problems. Okay, let us take one example based on this. Then we go for the calculation part. So what is the basic relation which we have written? 1 mole is equal to 6.023 into 10 to the power of 23 molecules, which is equal to 22.4 liters and which is equal to its gram molecular weight. Okay, now based on this, let us generate a question. So let us generate a question. What is the volume occupied by 1 mole of CO2? 1 mole of CO2. So here 1 mole is equal to Avogadro number and 1 mole is also equal to 22.4 liters. Means 1 mole of any substance. So we can write 1 mole of oxygen contains Avogadro number of oxygen molecules, occupies the volume of 22.4 liters and weight is equal to gram molecular weight of oxygen. That is 32 grams. Right. So 1 mole of carbon dioxide is given. What is the volume they asked? According to the relation, directly we can write 1 mole of CO2 occupies, what is the volume here? 22.4 liters. Simply directly we can write this. Okay, now let's take an example. Consider as example number 1. Take 1 mole of hydrogen gas. Consider 1 mole of hydrogen gas. So let us relate it. 1 mole of hydrogen. Hydrogen gas is what? It is a diatomic molecule. So it contains Avogadro number of molecules. So 1 mole of hydrogen is equal to 6.023 into 10 to the power of 23 hydrogen molecules. Because it contains same number, Avogadro number of same kind of particles. So 1 mole of hydrogen contains 6.023 into 10 to the power of 23 hydrogen molecules. Right. Now we can write 1 mole of hydrogen volume, let us occupies 22.4 liters. 22.4 liters. Now you consider the weight. 1 mole of hydrogen is equal to gram molecular weight of hydrogen. So what is the gram molecular weight? Weight of a molecule in the grams. So what you can write here, as 2 hydrogens are present into 1 gram, that is 2 grams. So we can write 1 mole of hydrogen weighs how many grams? 2 grams. In 1 mole of hydrogen, 2 grams of hydrogen is present. Are you clear? In 1 mole of hydrogen gas, 2 grams of hydrogen is present. Or 2 grams of hydrogen molecule or hydrogen gas contains how many moles? 1 mole. Are you clear? Let's take one more example here. Let us take one more example so that easily you can understand. So take example number 2. Consider 1 mole of methane. So the chemical formula for methane is CH4. CH4. Right. So take 1 mole of methane. 1 mole of CH4. Methane is CH4 is equal to Avogadro number of methane molecules 6.023 into 10 to the power of 23 molecules of methane. Because 1 mole of any substance contains Avogadro number of same kind of particles. Okay, right? And take in terms of volume, 1 mole of methane occupies, at STP 1 mole of gas occupies how much of volume? It is 22.4 liters. 22.4 liters. And take 1 mole of methane is equal to gram molecular weight of methane. So the weight of 1 mole of methane is equal to its gram molecular weight. So what is the gram molecular weight of methane? Let us find the molecular weight. What is the formula? CH4. You know well how to find the molecular weight. We discussed very clearly in the previous videos. So we have to write number of atoms of carbon, that is 1, into its gram atomic mass is 12 grams. Plus we have 4 hydrogens here, so we take 4 into gram atomic mass of hydrogen is 1 gram. So we can write 1 into 12, 12 grams, plus 4 into 1, 4 grams. We get the mass as a 16 gram. This is the gram molecular mass of methane. So that is, you can write here 16 grams. So 1 mole of methane weighs how many grams? 16 grams of methane. Okay. 1 mole of methane weighs 16 grams of methane. The same way, in a 16 grams of methane, how many moles are present? 1 mole is present. Are you clear? Now, based on this, let us solve some problems. Okay. Right. Now, here I'll give you a question. Right. So here we just write a question. Calculate the volume occupied by 4 moles of oxygen at STP. So this is the question given to you. What is the question here? Calculate the volume. We are supposed to find the volume occupied by 4 moles. Number of moles they mentioned, 4 moles of oxygen. So this can be calculated in 2 methods. This problem means this kind of all the problems can be calculated in 2 methods. Right. Let us see the both methods. So consider the method 1. You can follow whichever you feel easy. For your easy understanding, I am telling you the both. Okay. Right. So consider the 1 mole. 1 mole of O2 occupies how much of volume? That is 22.4 liters of volume at STP. At STP conditions, 1 mole occupies 22.4 liters. And what is the number of moles given? 4 moles of oxygen is given. And what is the volume occupied? Is it known? No. We have to find it. So, assume that unknown value as a x. Assume that unknown value as a x. Now, we can go for the cross multiplication. To equate the both, we'll go for the cross multiplication. That means you can write x into 1 mole, that is equal to 22.4 liters into 4 mole. Now take all the numericals at one side. So we get x is equal to 22.4 liters into 4 moles by 1 mole. So mole unit get cancelled. So something is divided by 1, we get the same value. So we can write x is equal to 22.4 liters into 4. So so here what we get? 22 4s are 88. So 4 into 0.4, that is 1.6. So we get 88 plus 1.6 in the sense 89.6 liters. This is the volume occupied by 4 moles of oxygen at STP. Now directly we can solve this problem by using the formula in order not to waste the time. So let us see what is the formula we use. Volume of a gas is equal to volume of a gas is equal to number of moles given into molar volume. So this is the formula we use. There is a condition. This is the formula we use when number of moles are mentioned or number of moles are given. Okay, if number of moles are given in the question, we can use this formula. Volume of a gas is equal to number of moles given into molar volume. Right? So what is the number of moles given in the question? 4. So 4 into what is the molar volume? That is 22.4 liters. So simplify this, what you get? 89.6 liters. So instead of going for the complete process, in a single step by using the formula, we can solve this problem. Are you clear? So this way we can find out the volume occupied by any gas or any number of moles of a gas. Okay. So in the next video, we shall discuss how to find volume of a given mass of a gas and a given number of molecules of a gas. So if you feel it is a useful video, please subscribe the video and share to your friends. Thank you.